Hello everybody, these are the video notes for lesson 5.2, graphing inequalities. Something that I've done for these notes to set it up that you can do as well is I've divided the paper into fourths. So I just folded it and then drew lines. So I have 4 quadrants because we're going to be doing 4 examples for these notes. Example number 1 is we're going to graph an equation. And this is something that you did a lot in semester 1. And the equation that we're going to graph today is y is equal to negative 2x plus 3. To graph this, let's make a xy coordinate plane. For these notes, it's a lot easier if you use graph paper. And there's extra graph paper in your module workbook. So something that you can do is flip to that section of your module workbook and use that. I'm doing, you want about 5 units on each axis. To graph the equation, we have 2 pieces of information because this is in slope intercept form. The slope is negative 2, that's what's being multiplied with x, and the y-intercept is 3. So to graph this, I'm going to use this y-intercept of 3. I'm going to go on up 3 on the y-axis, 1, 2, 3. That's going to be my first point. And then the slope is negative 2, so that means from this point, it goes down 2 units and to the right 1. I'll put my next point there, down 2 units and to the right 1. And now I can use these points. I'm going to connect them with a straight line. I'm going to use a straight edge for that. And there's my line. And so my solution set means, what are all the possible solutions to this equation? In this case, the solution set is all the points on the line. What that means is if I took any point that's on this line and I plugged in the x and y values of that point into this equation, I would get a true statement. So for example, this point that I'm touching right here, that has an x of 2 and a y of negative 1. So if I plug in an x of 2 and a y of negative 1 here, I would get a true statement. And I could do the same thing for any other point, the infinite number of points on this line. Let's do another example. This is example number 2. In this one, I want you to write y is less than negative 2x plus 3. And let's do a xy coordinate plane again. And we can do 5 units on each side. To graph this inequality, notice that it is almost exactly the same as our first example. The only difference is instead of an equal sign, we have this less than symbol. We can use the same pieces of information. We can use this slope. We can use this y-intercept. Let's do that. So the y-intercept is 3, so we're going to go up 3 on the y-axis. Slope is negative 2, so from over here we go down 2 to the right 1, down 2 to the right 1. And here's where it gets a little bit different. because it's not y is equal to, it's y is less than, what you're going to do is I'm going to connect these points with a dashed line. So it's not going to be fully connected. Like that. And then what I'm going to do is I'm going to shade all this area that's underneath this dashed line. And what I'm even going to do is also, I'm going to draw arrows pointing down from this line as a reference, just to make it even clearer. Because my solution set now is, instead of the solution being all the points on the line, it's all the points below the line. Because it's y is less than, that's why we're now looking at everything below the line instead of everything on the line. What this means is I can pick any point that's in this shaded area below this line, and if I plugged in the x and y values of that point into this inequality, I would get a true statement. Okay, so less than means below the line. Let's do another example. In this example, this is number 3. We're going to do y is less than or equal to negative 2x plus 3. Let's graph it out. Okay, you can do this same thing, set up our xy coordinate plane. Okay, and we're gonna use the same set of starting points, right? Because we have the same slope and the same y-intercept. So let's put the y-intercept in, and let's put in the slope, -2, rise of -2, run of 1, down 2 across 1. And now that we have our reference points, in this case, you can start by connecting them with a fully drawn out line like that. And then we're going to shade in everything below the line again. Just like that. And you can draw the arrows pointing down again for reference. These down arrows are not required. I just draw them in so that it helps you see that we want everything below the line. And now our solution set is going to be all the points on or below the line. Because this inequality is saying less than or equal to, that means that for this to be true, it can be any point on the line as well as anything below the line. So that's why, right, the difference is in here, we fully draw this line to show that points can be on it, whereas this one, we do the dashed line because we can't have points on the line, just everything below it. So that's the difference between these two examples. And we'll do one more example. And for this one, we're going to do y is greater than negative 2x plus 3. Same xy coordinate plane. And we have the same slope and the same y-intercept, so we'll graph those out. Okay, since we now have greater than, for your reference points, let's do a dashed line. So not a fully connected one, a dashed line. Like that. And this time we're going to shade everything above our dashed line. And if you want, you can draw in reference arrows pointing up. And our solution set for this one, because that's now y has to be greater than negative 2x plus 3, we want everything above the line. And because it cannot be equal to, it has to be greater than, that's why we're using this dashed line. The solution set is all the points above the line, but not on the line itself.